Thanks all for showing up and to here's this little chat we've got going on. Just to introduce myself, my name is Robert Fernandes, and I've been at Netflix a little over 6 years. I spent 4 years as an engineer in the Open Connect group working on content delivery, and for the last 2 years I stepped into a leadership role to manage the tools team that helps build solutions and automations for Open Connect. So I'm going to kind of give you a whirlwind tour of things about a CDN, why it's important, what it's actually, its purpose is, why Open Connect was built and determined to leverage and build that within Netflix itself, and then kind of just run through a bit of what my team does, what kinds of solutions that we try to solve, what kind of problems we try to solve within Netflix, and give an interesting spin there. So let's begin from the top. So who here believes they're familiar with a CDN and what its purpose is, what it's all about? Would say they're very familiar with it.
Vaguely.
Vaguely familiar? Yeah, that's fair. So essentially, this is a broad definition of what a content delivery network, also known as content distribution network, as you may have heard it. Delivery seems to be the more common terminology and phrase used. It's just the process of taking a bunch of content servers, distributing them geographically to get content closest to those who are requesting and needing to have the content, and then providing a means and a ways to direct those who are requesting the content to get it from the right place, the most efficient place, be that the most efficient server and or network path. So to kind of break that down a little bit and give kind of a high level, this is a grossly oversimplified view of the internet, especially from the residential space, where there are a bunch of end users who are connected with ISPs that actually deliver them content. And then there's larger, more aggregated networks that kind of interconnect those providers together. And some of those smaller providers and bigger providers are kind of aggregated into one. We think of something like Comcast or whatever, but that's generally how it works. And so if you want to do something like deliver a piece of content like Stranger Things, one of the options is just throw it up at one of those more collective places. So if you put that at one of those more aggregated locations, there could be potential unhappiness for you as a user. For obvious reasons, it may take you a long time, some kind of delay in getting the content, network hiccups, interruptions. So the further away the content is from you, the harder it is for you to get it. However, this also can make actual providers somewhat unhappy as well, which is the part that some folks tend to miss. And the reason for that being is that once you get to that level and it's providers talking to other providers, that content that's delivered is actually metered. So there is a cost to the, typically in megabits or gigabits per second, there's some kind of money transfer that changes hands based on the bits that are being delivered between those providers. Also, those things, when they have lots of traffic, can, of course, get congested. So when you're talking about something like Netflix, which is delivering streaming media, which can be very large file sizes, it has been measured at over 1/3 of the US internet traffic during peak hours. So that means like 33% of all the bits that are being delivered are coming from Netflix sources during those times. So that means the internet can actually be broken in pretty amazing ways when you try to shove a whole bunch of that data through very singular locations. So alternatively, this is what we do. We take that content, we distribute it on servers that are closer to the users, residing with the ISPs in many cases, which now kind of frees that up. You have a better user experience, we have more efficient delivery. The ISPs are happy because we've minimized their costs, we've minimized congestion, the transit connectivity that they have to provide, and we haven't broken the internet. So this is something, it's a pretty standard problem that many companies are trying to be good stewards and solve. So of course, Netflix is one of them, but think about YouTube, Apple and their store for delivering updates and their own media, Facebook. So there's a whole consortium of companies that say like, hey, this is the thing we need to solve because it's a better experience for our users and just a better cost savings and efficiency if we do things this way. So Open Connect, let's talk a little bit about why that exists and how it came about in this whole Netflix streaming story. So kind of explain where this fits in the entire picture. You load up Netflix and you actually want to, it's time for you to sit down and consume some content. The first thing is you just start up the application, whatever device you have it on, your TV or mobile device. It goes through an initialization process to kind of basically get the app up and running. It does some authentication. This is where a lot of the well-known things of like, hey, Netflix works a lot with AWS, a lot of the compute is in the cloud. This is where a lot of the services run. So this is where that starts to begin. Once all that's set up, you're now ready to figure out what it is that you want to watch. So you do your browsing, you do your searching, you look through your recommendations, and decide when you're ready for what we call playback. So once you've hit that play button, and it starts to say, hey, fetching content, this is where content delivery picks up and kicks in. And so this is where we sit in that content delivery area. And then once the content has started streaming, there's then some interaction between the client and the content delivery network to basically to make sure that you have an optimal experience even as network conditions might change or as you're watching something. Things can go up and down, and we want to make sure that you're not rebuffered, that like the play experience is very smooth. So there's a bit of communication between the two to make sure that that happens. Another small interesting tidbit is that without content delivery in the mix, it's not just the actual streaming content itself, but all of the box art, the trailers, the screenshots, everything that you see there is delivered via the CDN. Also, the actual JavaScript assets, which are loaded into the application and actually make the application run, are part of content delivery as well. So it's a very multi-tenant service at this point that has multiple functions. And so it's about making the application function and also delivering the content at this point. So Netflix streaming launched in 2007. In 2009, this is essentially the story of what things look like. There was the Netflix content control plane, NCCP. That was basically the streaming part of the Netflix product. That was a kind of second bullet of what a CDN is. That was the cloud functionality we provided to make sure you were steered to the right place to get the content. However, the actual delivery of that content was done by an aggregate of third-party providers that we use to actually deliver that content for us. So we just had to make sure we handed the content to the right places. Those providers put it on the edge for us, and we just had to make sure that when you clicked play, you got to the right place to have it delivered from someone who had the content. However, fast forward a couple of years, and this is when Netflix Open Connect was launched. A very enterprising individual within the company had some conversations with Reed and some of the product leadership and basically said, look, we have a lot of experience working with these CDN providers. We know how this works. We believe we could provide a similar solution that's custom built for Netflix that would be more efficient and better for the business if we were to kind of build this as opposed to buy it. So what that meant was, well, beyond the fact of first we just had to deal with getting you to the right content that other folks were providing, of that we now became responsible for the entire end-to-end process of getting those servers into the right places, making sure the content was there, making sure those servers were up and running and doing the right things. So that kind of expanded the whole scope of what was being done with relation to content delivery inside of Netflix. Drilling in a little bit to what that physically looks like, And I'm going to say this because I can't stop myself from saying Open Connect Appliance or OCA just being ingrained in Open Connect for so long. So if you hear me reference that, all that means is that is the actual physical servers that we're using which store the content that is delivered to the end users. And there are actual a couple of different varieties of that. We have what's known as our storage appliance, which essentially is for storing large bits of the catalog on spinning hard disk drives. So that's where we try to hold the majority of things. None of these, including stacks of them, generally hold the whole catalog. They hold portions, but for the majority of things that aren't necessarily the most fetched or the most popular, we can get away with storing them on these drives that can hold more content but may not be quite as efficient at reading or writing or don't necessarily have as much throughput. But does the job for the majority of things. And alternatively, we also have another version that is a flash appliance, which instead of spinning drives have these spinning platters and have arms that move and read off of the disks. They're solid state drives, so they are not quite as efficient cost-wise in their storage capacity. However, their throughput is actually much greater, their performance is much higher. So it's then finding a balance of how do we build out the right sites that have the right amount of flash or offload appliances versus storage that can get the right amount of content based on the user base that it's trying to serve and what catalog we need to have in those locations. This is currently all of the places where OpenConnect has deployed servers. We have thousands of sites, over 10,000 appliances. The indication there of those different color variants is we actually have two types of sites. The green ones are ones where we have what we call an embedded agreement, where we actually take those servers and we hand them off to the ISPs. They provide the space, rack, power, cooling, and all the things to actually maintain the server physically. And then we connect with them via their own infrastructure. The orange locations are Netflix IX or Internet Exchange locations, where Netflix actually controls and manages the hardware. And it's in some general location where other ISPs exist and have connectivity. And we just, via network, we just peer with them, and we're the ones who actually deliver the content for them. But as you can see, the vast majority of the OCAs that we have deployed are actually in embedded locations throughout the world. It was another one of those reasons that the efficiency of building this solution within Netflix made so much more sense, because we were able to reach other parts of the globe as Netflix scaled. I believe it was in 2016 when we did the global launch. We announced 130 additional countries to the service. Now, as of this year, we're over 190 countries. So making sure we have the content in the right places for what parts of the catalog are in those parts of the world is something that we can just much better solve internally than trying to hand that off to another provider. It's not just about servers. There's also a network component involved. So what this map is of the Netflix backbone network, where we have connectivity to make sure that we are able to efficiently fill content. Basically, what fill means is, given that these locations can't store all of the catalog that's needed, they just try to find the most efficient offload to get the most content off of transit as possible. But that changes over time. As new things are released, as things get a little older, may fade in popularity, which content we want in which places changes. So there are some processes that run to make sure we know what things need to be in the right place in the future. And the OCAs basically phone home and say, what is it that you want me to have on my system? And then during off-peak hours, when everyone in their own time zone is asleep, there's not a lot of traffic, costs actually go down for some of this more type of transit activity because there's no congestion. That is when most of the new content that needs to be in place happens. So we need to make sure we have good network connectivity to get these large files to the right places so that they're in place. It's a tiered mechanism so that there's a few locations that do store the entire catalog. They dump the right things into current regional locations, and then they essentially just peer fill between themselves. So if there's 30 machines in a stack, only a couple of them actually have to fetch the content, and the other 28 can just fetch it locally from within its own local network to kind of, again, save. So that's a bit of history about CDNs, about Open Connect. Now I'm going to talk a little bit about what it is that our team does and how we came about. So within the Open Connect organization, there are just kind of some natural verticals that kind of grew out of having to take over all of these parts of content delivery, what parts of the business were actually established. So there's like a development group that basically is in charge of speccing out what these revisions of hardware are that we're going to deliver on an about annual basis. There's typically 1 or 2 new revisions of each hardware type that kind of come out that we deliver on that have new components, new technologies, so we're constantly keeping that up to date. There's a group of folks who work on the actual firmware, the OS that runs on these machines, which is a custom fork of FreeBSD. That could probably be a whole separate talk of like why we actually choose and what that OS looks like and why we do that, but there's many reasons. And then there's the group that's actually building out the control plane. So that was all the kind of stuff we were talking about with the CDN, but if you actually want to run this thing, there are many more things involved. We talked about the network, which is kind of the last picture that I've shown, that there's making sure we're provisioning the right network things and getting a good cost for those over time as the landscape changes. There's an operations component. So we actually have to make sure this thing is up and running, and that it's doing the right things, and that we have the right communication set up with partners so that we can make sure things are going right on their end for the ones that actually do have the embedded OCAs in their installations. And then just general business operations type of things. Doing CRM, shipping things around, managing these partnerships with all of these ISPs. There's a lot of logistics around that and making sure all the right things are happening from the business sense. And what kind of organically happened is that as these groups were kind of growing and finding their purpose and what they needed to do, they wanted to start building some tooling and automation. So essentially kind of each group had their own small sub-team that was kind of looking to solve the problems for what was going on kind of in that vertical within Open Connect. Kind of was discovered that that wasn't scaling entirely well and that there might be some efficiencies gained by collectively combining those groups into one who could kind of look at the overarching set of needs within Open Connect as a whole and trying to build more general solutions that could handle some of these cross-functional concerns or kind of step out and make sure there wasn't any duplicate effort between these groups and the types of tooling that they needed and so on and so forth. So hence this team was born. And essentially what our charter is to design and build solutions to help Open Connect operate as one of the key words more efficiently and reliably. So what exactly does that mean and what is in our scope? It kind of looks like this. We tend to focus on more of how the business functions, the Netflix user, not Netflix user, the Netflix employee experience and the things that they are dealing with on a daily basis to make sure Open Connect is running and functioning and delivering content. And when I mentioned the Open Connect control plane, that bit that's actually the cloud service that actually decides where within the CDN do you need to go to get your content, they have a set of problems that they try to solve. And that is, making sure that the right content is and is getting to the right places, that all of the security and geo things are in the right place. Netflix only serves certain parts of its content to certain parts of the world, just to how rights management works. It very much is depending on where you are sitting, depends what you can actually watch on Netflix. And those who would like to circumvent or get around that, the people who hold the license to the content make sure we're doing due diligence to make sure when you log in, you are who you say you are and you are where you say you are, so that we're giving the right things to the right people that we are allowed to. So those are the kind of concerns that they deal with, and We're a little bit on the other, more business-related side. So that's a long list. This is more of a picture of kind of what that looks like. These are the kind of focus areas that we care about. Inventory and hardware management, so working with our manufacturers and system integrators who actually build these machines. That middle thing represents our fill site, which what that represents is before we ship these machines out to these, especially these embedded locations, we don't want to have the partners plug them in and then suddenly have to download terabits and terabits. It would take them days to like pull all the content they need to get their initial set of content loaded. So we actually send them to a well-connected place in the US. We have them allocate, these machines are going to end up in this location, so please preload these bits of content because we know once it gets out in the field in that location, that's what it's going to want. So that the vast majority of the catalog for where that machine is going is already preloaded. So that's a whole process that we have to help manage of getting the right things to the right places, make sure they get the right things on them before they actually go out to the partners. And then obviously we have relationships with communications partners, ISPs, who actually are dealing with having this inventory on hand and taking care of it for us. And then there's many other things. Obviously, we have to ship these things around, so we have carriers that get these boxes from here to there. We have to manage those types of processes and relationships. The actual business functions within Netflix do matter to make sure we have the right legal agreements in place before we actually send something to a partner. When we actually are moving hardware between locations from us to a partner, depending on which country and what the legal rules are there, and accounting rules, like what happens when the machine changes hands, who quote unquote is the owner, what entity owns it. Making sure we have all of that accurate and reflected based on the state of what the CDN physically looks like is quite important. The actual operations of it, like I mentioned before, the operations team needs to be able to have insight of, are these machines alive doing the things that they need to do? We're dealing with hardware, so of course, it's not a perfect world. There's issues, things break, things happen. So then we have to deal with what do we do when those things happen? How do we deal with repairs? How do we deal with RMAs? How do we deal with end of life and cycling the hardware that exists out in the fleet? So what had kind of organically happened is, of course, in a group that's growing very quickly, there were a lot of organic processes that came about, and unfortunately a lot of them were quickly built solutions that looked at things like a lot of spreadsheets, a lot of just kind of cobbled together scripts to kind of automate some of these things. There's always, software is never short-lived, so always, someone hacked together a prototype of something that I built. We're only going to use it a couple times, and 3 years later, you're then trying to get rid of it still. Is always fun. And then just a lot of manual processes of email back and forth between different groups and between partners, actual phone calls, which are even worse to try to track down, like what actually happened on this call, who actually committed to what action item, what's happening. There's not a lot of insight into those type of things. So what we do is we try to build, more standard solutions that are engineered to help solve these problems. So more information systems, services, workflows, and automation that they will never replace all of the other processes that are going on. There's always going to be a spreadsheet somewhere. There's always going to be someone manually tracking something somewhere. There's always going to be phone calls happening. We're not going to automate away the world. We don't have that kind of pipe dream. But we would like to make that as small as possible so that those within Netflix who are working on the CDN have the ability to do that better. So what does that look like? Essentially, this likely looks somewhat how the business is structured. There were just some general natural kind of verticals from a software perspective that came out of this. There were applications that dealt with kind of the hardware and inventory management side of things. Another rather large web application that dealt with the configuration management of how do you actually set the properties and configure all of these machines out in the fleet to make sure they know what they're supposed to be doing where they're sitting. From our operations side, monitoring, obviously, as we said before, was very important so that we were able to have insight into what was going on in the live running service. And then a bunch of other, that last box there is actually multiple applications kind of thrown into one. But essentially, this is what the landscape looked like for at least a couple of years. Very three-tiered web application type of stuff, persistence layer, middleware API layer, and then a UI that would sit on top of it. But relatively siloed in the areas, and as things were needed, they were just kind of added to that application. There were some platform services that were kind of built that were somewhat cross-cutting concerns, so like how we actually did all of our logging, how we did telemetry, so like, as our UIs were being used, that we could see like, what users were doing, where things were failing. So some of those services did exist, but in general, it was quite a bit of large three-tiered web applications that got built. And as you can see, the reason that top dashed line exists is the vast majority of what we build is internal to Netflix, and is for, Netflix folks to operate the CDN and run the CDN. But we do have also a small external facing component, which are like some self-service portals that we allow our partners into so that they're able actually to do some of these things of maintenance and insight themselves, and we don't have to rely solely on our operations team to do some of that. So I'm going to chat a little bit about what is our process and what is our thought in how we kind of get out from under that historical architecture that kind of just grew out of those silos that were kind of built. Little bit of a disclaimer here. We are not going to stand up here and say that everything needs to be SOA or microservices. There is a time and a place. There is a reason that a lot of these MVC server frameworks exist. ASP.NET, Rails, Ruby on Rails, Spring MVC. Those things exist for a reason. Those types of, opinionated and more patterned constructs, it's easy to ramp up on them, it's easy to understand. There's a lot of flexibility of, as things have changed, you don't have to do the full view layer within your server. You could just basically do kind of the model and controller and serve things more like web APIs out of these frameworks. So they're there, they do their job. If you've got a small scope project or a small team, this is a super easy way to start building out applications. They get leverage for a reason. However, if you start to deal with one of these things long enough, you might to notice some of these warning signs. A couple I will call out specifically. Scaling required for individual features is a very interesting one, where it's, if you have an application that deals with many different types of functions, say you're just basically doing certain CRUD operations, you have some background jobs that are kind of running on some kind of scheduler that are happening on the server, you have a search API that was actually like delivering filtered search results via your API, and you notice that perhaps you start having to scale up or add more capacity, like solely for the intent of search, and that's making all of the other parts of your application suffer a bit because there's just some part of your application that is taking up most of the resources or compute time or whatever. Second to last one, also we actually have seen a bit of when tech ops greater than development. So it basically means if you're spending more time trying to keep the system alive and not disrupting other services than you are actually developing and working on the service, it may be something that you want to take a look at. That last one is really a long-running joke, literally within the team of when you start seeing things in Slack, or it was like, is it okay if I have this new feature? Am I going to stomp on anyone's toes if I push? Is this okay? Can you watch this for me? Or no, I have to do yours after mine. Probably are a little bit of a flag. You should be like, oh, is this really how we should have this system running in the long term? The answer might be no. So this is at a high level kind of what we have come up with for our architecture and path moving forward, of going with a more layered approach to how we actually build and deploy these services. So, for example, we can start to leverage things between the control plane team and ourselves by just building one solution of a gateway of all the communication we have to do with these OCAs. If we have that all running through one place and one service that is built. That middle layer, that domain layer, is quite important to our future moving forward, of instead of having one application that is dealing with a lot of domains and a lot of different areas, that we start to decompose and break those down a bit and kind of have services that have one general concern and one type of area that they need to focus on. So we can scale those services independently, we can remodel that service independently and not have to worry about it affecting any of the other services that we have built. And like I said, that kind of tier on the very right there is kind of some of those cross-cutting concerns. Some of those services already exist for us. Some, like for example, I mentioned search. We happen to have search kind of distributed within all of those applications at this point. And we think we could get a lot more leverage if we extracted that and had a more common solution for searching all of the entities that we provide via some other mechanism. But then there is still well, now that you have all of these services, how do you deliver that experience to clients or UIs that need to consume them, which we'll get to in just a minute. So what this kind of boils down to is that we are going from a more application-centric, application-focused kind of architecture into just more of a platform-based one. For kind of all the reasons mentioned, all those red flags that were kind of noted, those are all ones that we've seen. So we would like to basically make our delivery how easy it is for us to design and deploy solutions. We can do much more efficiently, much more independently, and not a lot of having to deal with large complex dependencies, large complex interactions between things that live on the same application, and so on. This also lets us be very flexible and kind of take a step back and say, like, okay, one of our charters moving forward is to look at things like devices as not just OCAs. But if we wanted to do inventory tracking on devices in general, let's say network devices, routers and things, or storage or compute devices, we start to add those to the fleet, that we have the ability to manage devices as devices that can be general or more specific. Device can have components. So if we kind of extract that out and have its own thing, we can get more leverage and power by having a service that deals with that instead of OCAs on one and network devices on another, and having like these separate, very specific types of solutions to a more generalized one. So what does that mean within the area of user interfaces for us? As I said, those are not unaffected. As we start to break this down and decompose these applications, what do we do with these? So the kind of highlight areas, we have essentially an application, UI application per web application is kind of essentially what it looks like at this point in time. There's a sub-team that's focused on that application. They know what the, in general, REST APIs are for that web application. They know what UI they need to build on it. So very much one-to-one. But we're looking to break that apart. So what does that look like? In essence, we're kind of taking a step back, and it's essentially a bit more of the opposite of what we want to do with our service tier. So rather than saying, we actually want to break these down and have a UI per server, that doesn't make sense. Like, these things still need to interoperate, aggregate data together, tell a better story. So rather than looking at this from a domain or service level, we've kind of taken a step back and said, okay, what are our main user roles or user stories or user role, like what types of users do we support? And then we'd like to build UIs or applications around that, rather than this is the application, this is its API, this is what the UI needs to be built to serve that API. So having this stories of internal administration, which is most all of those UIs that were kind of aggregated at that one layer internally. We'd like to be able to send users to one logical place that may actually be a composite of a few different UIs, but at least give them this is the place they can go and launch to and give them access to all of the types of things they need to do and not have to do hardware type things in this application and configuration in this one and monitoring in this one. And where do I go to do what is something we'd like to alleviate. And then I still want to tell those external partner stories. But in that case, we have two essentially different types of partners. We have those ISP partners who are helping deliver content for us, and we have those integrator portals, which is more like the manufacturers, the fill site. They're kind of the behind-the-scene folks that are dealing with these machines before they get onto the live service. That's a bit of a different experience that we want to deal with. But what does that look like from a technology standpoint? What do we do when we have all of these services and we do need UIs that need to talk to them? And there's a couple different options. One, you can just go with a straight API gateway approach. There is a Netflix open source project called Zool. Many of you may have heard of it. This is essentially what fronts the actual Netflix service itself. When the client is communicating with it, it goes through this gateway. But in that sense, if that's your only solution, all that knows is the requests are coming into one place, and it's just sending them off somewhat directly to the services that are behind it. So it's essentially just somewhat unintelligent, and then all it knows is what the structure of your services are, like where they actually live and what it needs to get you to when you make a request. So second option is dealing more with API aggregation composition. There's basically some layer somewhere that actually can take that data and combine it for you in some means that give you a singular place to access that. Again, there's a Netflix open source project there called Falcor. That's what's leveraged kind of in combination with Zool to deliver the actual models for our API apps of the clients that we use. However, internally within Netflix, at least from the tools perspective and who are building internal solutions, there actually is another project that we've started leveraging onto, and that's GraphQL. It has very much trying to solve the same kind of problem that Falcor does, but in a slightly different way. Don't have time to go in too much detail here, but whereas something like Falcor can give you back an object and kind of know that to give you these objects, it has to go to different places to kind of combine and give you that object back in one form. GraphQL lets you be a little more verbose about that and kind of say, here's what my data model looks like. It's a typed system, so you actually can build types into it. So if you're using something like TypeScript or something like that on UI, making that translation is actually very easy. It allows you to do introspection on your model. There's a little bit more powerful query interface, so instead of just saying, I want these sets of things or this range of things, you can actually apply filters of, I want things with this name and these other fields that match this filter and hand that back to me. But in essence, that's the kind of layer that will handle dealing with all that for you, of knowing where all those services are that have the individual bits of data, combining them and giving them back to you in one place. This started as a Facebook initiative. They use it internally, and that has kind of grown out. Now there actually is a GraphQL foundation. There are a lot of contributing community members to that, so it's a very thriving community. There's a lot of support. As I said, there are a lot of groups internal to Netflix that are actually beginning to heavily leverage this just for all the benefits it gives you of being able to control what your model looks like, to have a type declarative system of what kind of data you're going to get back, and then how to build UIs around that. There's some very nice stories there. All right, so hopefully you're able to take a little bit of something. I know that was kind of a very broad sweep of covering CDN, covering OpenConnect, covering OpenConnect tools itself. If you have any questions, I'll be hanging around afterwards, kind of chat with folks. I'll also be heading over to our booth from 3:30 to 5 over in the Stifle Theater. We have the booth on the 3rd floor, I think, if you want to stop by and chat. In the Strange Loop Slack, we have a Netflix channel. So if you'd like to hop in there, ask any questions, ask anything about Netflix or about OpenConnect, happy to answer it. Then just a little plug, there is another Netflix chat on pattern matching with finite state machines that's next door tomorrow afternoon. So if you want to hear a whole different part and different story about Netflix, then feel free to check that out also. So that's all I got. Thanks.